Okay, so factor and remainder theorem, here's a practice question. So let's read the practice question very carefully. So the polynomial is 6x cubed plus ax squared plus bx minus 2, where a and b are constants, is denoted by p by x. So that means p of x is equal to 6x cubed plus ax squared plus bx minus 2. So this is the first step of first phase of solving questions. You have to get all the important data down first. It is given that 2x plus 1 is a factor. Keyword factor. I'm going to highlight this in like green as well, like factor. Of p of x. And that when p of x is divided by x plus 2, the remainder is minus 24. So x plus 2 is not a factor. Otherwise, well, you're going to get, when you put f minus 2, you will get minus 24. I'll show that later. This is just something you should know beforehand. Review this definition again. If a polynomial f of x is divided by x minus a, the remainder is f of a. And if a polynomial f of x is a factor x minus a. If you don't understand what this means, go watch my previous video where I explained it really in depth. Okay, let's try solving this question first. Okay, so 2x plus 1 is a factor. That means that since 2x plus 1 is a factor of p of x, that means when I divide p of x by 2x plus 1, which is its factor, the remainder should be 0, right? That's what the definition states. A polynomial of x is a factor if and only if the remainder, or f of a, is equal to 0. So that means that when I divide this by this, or this by this, I should get my remainder as 0. So we need to do p of a. How do we know what a is? Well, we equate the factor to 0 and find the value of x. That's how we find out the value of a. This is what I'm referencing when I mean the value of a. So 2x equals to negative 1, x is equal to negative 1 by 2. So since it's a factor, that means that when I take a, so the value of a is negative 1 by 2. Since it's a factor, the remainder should be 0. The remainder is p minus 1 by 2, which should be 0. So when we do p minus 1 by 2, we have to replace every single instance of x with negative 1 by 2. So 6, negative 1 by 2, cube, negative 1 by 2, squared, plus b, negative 1 by 2, minus 2 is equal to 0. So negative 6 by 2 cube is 8, plus minus 1 by 2 squared is positive 1 by 4 because we're squaring it. So a by 4, negative b by 2, negative b by 2, minus 2 is equal to 0. So let's make that into an equation, making a and minus b. So minus 6 by 8, let's keep a over here. Uh, 2 plus 6 by 8, I'm going to move it, I'm going to solve it over here, simplify it over here. So that would be a by 4 minus b by 2 is equal to, just use your calculator for this, 2 by 3 by 4. So that's 11 by 4. So there's a rule in math that says that the number of variables that you find, that is how many equations you should also form. So here we have 2 variables that we need to find, so we should form 2 separate equations. We did the factor portion, but we can now focus on the remainder portion. This will be the same procedure. We're going to have to equate x plus 2 to 0 to find the value of a. So x plus 2 equal to 0, x is equal to negative 2. So a is equal to negative 2. And it says that when p of x is divided by x plus 2, the remainder is minus 24. And you know that the remainder is f of a, right? And the value of a is negative 2. That means p of a should be equal to negative 24. So a is minus 2. And now we just replace every instance of x with negative 2. So 6 negative 2 cubed plus a negative 2 squared plus b negative 2 minus 2 is equal to negative 24. So that should be, negative numbers when cubed still stay negative. So 6 into 8 is minus 48. Negative number squared is positive, so plus 4a, and negative 2b minus 2 is equal to negative 24. And let's keep a and b on one side of the equation and move. So minus 48 minus 2 is equal to negative 50. So that becomes positive 50 minus 24. So 4a minus 2b is equal to 50 minus 24. That's 26. Okay, we have two equations for a and b. We have two equations for a and b. So the next step in solving it is using simultaneous equations. So given that you're in A2 level, you're expected to know simultaneous equations. I'm going to assume you know simultaneous equations, so I won't be explaining too in depth because it's quite required as an A2 student. So first we find the value. First we find a value of a. How about I do it on a separate page? Rotate this page. Counterclockwise. Yeah. Okay. So we have two values. So we have two equations. A by 4 minus b by 2. 11 by 4, and we also have 4a minus 2b is equal to 26. Okay, let's find the value of a and plug it into the other equation. That's the whole process. So a by 4 is equal to 11 by 4 plus b by 2. A is equal to, now move 4 over here, so that's 44 plus, actually, there's a better way of solving this. So we take the LCM, and we need to take the LCM as 4. So we need to multiply this by 2, and we need to multiply that by 2 as well. So 11 plus 2b. And when you move 4 over here, actually, let's just show it. Cancels with the 4 here, so a is equal to 11 plus 2b. Okay, so we have one value of a, and then we plug it in over here in this equation. So 4, 11 plus 2b minus 2b. I'll move this piece of paper down. Okay, so minus 2b is equal to 26, and that's 44 plus 8b minus 2b is equal to 26. 44 plus 6b is equal to 26. 6b, 26 minus 44. 6b is equal to minus 18. b is equal to minus 18 by 6, which is equal to negative 3. So that's one value of b. And using that, now we can plug in the value of b that we found over here into this equation to find the value of a. And we found the value of b as negative 3, so plus 2, negative 3. A is equal to 11. This should be negative 6, because 2 into 3 is 6, so 2 into negative 3 is minus 6. So a is equal to 5. So our values are a is equal to 5, b is equal to negative 3. So therefore, p of x should be equal to 6x cubed plus 5x squared minus 3x minus 2. And that's the question solved.